Example 2 says, suppose that an airplane is asked to stay in a holding pattern near an airport. The distance of the plane to the airport is described by the following function. D of t is equal to 144 plus 67 times the sine of 2 pi over 12 times t. In this equation, d of t is the distance of the plane to the airport in miles, and t is the time in minutes after the plane enters the holding pattern. During the first 12 minutes after the plane enters the holding pattern, when will the plane be 190 miles from the airport? Round your answer to the nearest hundredth of a minute. So we want to know during the first 12 minutes, when will the plane be 190 miles from the airport? D of t is the distance of the plane to the airport, so this 190 is going to go in for d of t. And it will look like this. 190 equals 144 plus 67 times the sine of 2 pi over 12 times t. And then what we want to do is we want to solve for t. So this is going to be very similar to example 1. But instead of using a cosine function, we're now going to be taking a look at the sine function. We want to isolate that sine function first because our angle is stuck inside of it. To do that, again, be careful of a big mistake, which is adding these two together. You cannot add these together as this 67 is attached to the sine. So we have to subtract that 144 first. And if we subtract 144 from both sides, we end up with 46 on the left, equal to 67 sine of 2 pi over 12 times t. Then what we need to do is divide both sides by 67. So we get 46 over 67 equal to the sine of 2 pi over 12 times t. Now that we have the sine all by itself, what we're going to do is make it a little easier on ourselves by substituting out what's inside here and letting our angle just be one variable so that we can use that to start. So we are going to use u. You can use whatever variable you want. It doesn't have to be u, but I'm going to let u equal 2 pi over 12 times t. So then what I'm looking at here, let's fix that. So then what I have, if I let u equal that, is 46 over 67 equal to the sine of u. And just like before, there are two places on my graph where the sine function is positive. Remember, we were using the cosine as negative. Now we're using the sine and saying that it's going to be a positive number. Well, sine is positive in the first quadrant and the second quadrant. So what we're looking at in terms of rotation of angles is we have one angle here where we've rotated from here to here, and we have one angle in the second quadrant. So we've rotated from here to here. And what we want to use are those reference angles. So this would be the reference angle here. In the first quadrant, you don't need a reference angle. You're just using the inverse. Remember, this is pi. So if we want to use the angle in here, we're taking pi minus that reference angle. So we can set up two equations here. We can say that u is equal to the sine inverse of 46 over 67, or we could say that u is equal to pi minus the sine inverse of 46 over 67. Remember that what you set u equal to is not going to be the same every single time. It depends on what function you're starting with and where it lies in your quadrants. Okay, remember cosine, if cosine's negative, it's going to be in these. If cosine's positive, it will be over here. If sine were negative, we would be down here, and you have to think about what you're adding or subtracting. It's not always going to be the exact same. Then what we need to do is we need to replace u with what we had originally. So we're going to take u and replace it now with the 2 pi over 12 times t equal to the sine inverse of 46 over 67. And over here as well, we'll take the 2 pi over 12t equal to pi minus the sine inverse of 46 over 67. If I solve the first one, I want to multiply by the reciprocal, which would be 12 over 2 pi. So t is going to be equal to that reciprocal, 12 over 2 pi, times the sine inverse of 46 over 67. Please type this into your calculator. Make sure you're typing it in correctly. If you type it in correctly, you should get that to be approximately 1.45. We're talking about minutes. If we solve the other one, we're doing the same thing. We're going to multiply by that reciprocal. So t is going to be equal to 12 over 2 pi times pi minus the sine inverse of 46 over 67. Again, plug that into your calculator. Make sure what you're typing in is coming out the same as what I have, which would be 4.55 minutes. If it's not coming out correctly, let me know. I can take a look at your calculator and help you figure out where your mistake is. If you have questions on the problem in general, again, let me know. Otherwise, we can move on to the next example.